Hello, my friends. Welcome back. I'm sure you feel amazing after having built your very first artificial neural network. But remember, that's only half part of the job. The second half will be, of course, to train it on the whole training set. And we are going to do this in two steps. The first one is to compile the ANN with an optimizer, a loss function, and a metric, which will be, of course, the accuracy because we're doing some classification. And then the second step will be, of course, to train the ANN on the training set over a certain number of epochs. Are you ready? Let's do this. Starting with this first step, compiling the ANN. All right, so once again, doing this will be super simple thanks to the TensorFlow library that integrated Keras, because indeed, to compile our ANN, we first need to start from our ANN object, which I remind was created as an instance of the sequential class. And then from this object, we're going to call a new method, which this time, of course, won't be the add method. But can you actually guess what this method is going to be? You know, there is no trap TensorFlow nor any confusion. Well, the method to compile an artificial neural network is simply the compile method. As simple as that, right? We didn't even have to look at the TensorFlow documentation, which, by the way, I still recommend to have a look at because you will get a lot of information on the diverse tools you have in the TensorFlow library. But here, it's super intuitive, it's super easy. So now I have a next question for you. According to you, what do we have to enter as parameters inside this compile method? Well, I actually said it. We have to enter three parameters. The first one is the optimizer, to choose an optimizer, then the second one is the loss, to choose a loss function, and the third one is the metrics with an S parameter. Because know that you can actually choose several metrics to evaluate your ANN at the same time, but we will only choose one, and we will choose the accuracy. But there you go, these are the three parameters. So I suggest that we start by entering them, and then we'll enter their values. Okay, so let's start with the first one. Optimizer equals, all right, then comma. The next one is the loss for the loss function. And finally, the third one is the metrics parameter. All right, so for the optimizer, which one would you like to get? Well, in the intuition lectures, Mumbles mentioned that the best one are the optimizers that can perform stochastic gradient descent. And the best of them, the one that I recommend by default is the Atom Optimizer, which is a very performance optimizer that can perform the stochastic gradient descent. And by that, let me just remind what stochastic gradient descent allows to do. Well, it is what will update the weights in order to reduce the loss error between your predictions and the real results. When we train the ANN on the training set, we will at each iteration compare the predictions in a batch to the real results in the same batch. And that optimizer here will update the weight through stochastic gradient descent because we're going to choose the Atom Optimizer to, at the next iteration, hopefully reduce the loss. All right? So that's why right here we have to choose an optimizer, but also a loss function, which is the way to compute the difference between the predictions and the real results, and then the accuracy, of course, because that's our final evaluation metric. All right, so as we said, we're going to choose the Atom Optimizer, and the code name for that is simply, but with no capital letter, Atom. Okay, congratulations. Now you know how to compile an artificial neural network with an optimizer, but then we also have to compile it with a loss function. And now you have to know something very important when you are doing binary classification. Classification when you have to predict a binary outcome. Well, the loss function must always be the following one entered in quotes, of course, which is binary underscore cross entropy, just like that. And now let me tell you what you would have to enter if you were doing non-binary classification. Like, for example, predicting 3 different categories. Well, here you would have to enter a category called cross-entropy loss, okay? For binary classification, the loss must be binary cross-entropy. And for non-binary classification, the loss must be category called cross-entropy. And then also, when doing non-binary classification, when predicting more than 2 categories, well, the activation should not be sigmoid, but softmax, right? I take this opportunity to also give you the other cases of classification, which you could encounter. Okay, so now you know everything. And then remember that for regression, because we can also do artificial neural networks for regression, while we have this free course, which I give you the link, you can just take this course for free and you will get the full implementation of an artificial neural network for a regression case study. So you have really everything that you can do with an artificial neural network. All right, great. And now let's enter the final parameter here, metrics. As I said, we can actually choose several metrics at the same time. Therefore, in order to enter the values of this parameter, well, we have to enter them in a pair of square brackets, which is supposed to be, the list of the different metrics with which you want to evaluate your ANN during the training. But we will only choose the main one. The most essential one, which is the accuracy in which you have to enter in quotes. All right, accuracy, just like the classic spelling. And now, congratulations! You know how to do a full compile of your ANN with an optimizer, a loss, and some metrics. Perfect. So now let's move on to the ultimate step, meaning the step where we will train the ANN onto the whole training set. So let's create a new code cell. And now, according to you, how do we need to start this training? Well, once again, it's always the same thing. We need to take our ANN object, then call a new method, which will perform the training, and then enter a couple of parameters. So let's do this. Let's start with ANN first, our object, and then according to you, what will be the method that can train your artificial neural network on the training set? Well, nothing has changed here. And actually, I think I said it earlier in the course, the method to train whatever machine learning model is always the same one. It is the fit method. The fit method, in which we'll take always the same parameters. The first one is xtrain for, the matrix of features of the training set. Then train for the dependent variable vector of the training set. And then when training an artificial neural network, we actually need to enter two more parameters, which are first, the batch size, because indeed batch learning is always more efficient and more performant when training an artificial neural network. Meaning that instead of comparing your prediction to the real result one by one, to compute and reduce the loss, well, you are going to do that with several predictions compared to several real results into a batch. And the batch size here, the batch size parameter gives exactly the number of predictions you want to have in the batch to be compared to that same number of real results. And the classic value of the batch size that is usually chosen is 32, right? If you don't want to spend too much time tuning this hyperparameter, well, I recommend to choose the default value, 32. But anyway, I wanted to highlight that hyperparameter here because indeed it is very important to remember that we're doing batch learning. Okay, so batch size equal 32, and finally, I'm sure you know which final parameter we have to enter here. That's, of course, the number of epochs. A neural network has to be trained over a certain amount of epochs so as to improve the accuracy over time. And we will clearly see that once we execute this cell. So the name of the parameter for the number of epochs is simply epochs. And while you will see that, it'll go very fast. So we can just take 100 epochs. But once again, feel free to choose another number as long as it is not too small. Because your neural network needs a certain amount of epochs in order to learn properly. Learn the correlations to get the ultimate best predictions. All right, great. So we're actually done with part 3 now, so I suggest we no longer wait and that we execute all the cells we haven't executed so far, which I think, start from part 2, right? Yes, this was the last cell of the data processing phase. It was run properly, so let's actually run each cell one by one and see what we're going to get in the end during the training. So let's start with this one, initializing the ANN. Good. Now this one adding the input layer and the first hidden layer. Good. Now this one adding the second hidden layer. All good. And now this one adding the output layer. All good. Still. Now we enter part 3, executing first this cell, compiling the ANN. All good. And now are you ready, my friends? We're about to train the artificial neural network on the training set, over 100 epochs. And here we go. The training is starting, and as I told you, it's going pretty fast, but look at this. Look at the accuracy and how it is evolving over the epochs. And we can see that it is actually increasing pretty fast. And mostly we see that it is actually converging, converging pretty quickly. We converged at all point 86, at about the 20th epic. We actually didn't need that 100 epics, but 20 was fine. But anyway, it's going really fast, and I'm sure it's very over soon now because, indeed, yes, there we go. The training was done in more or less 20 seconds. And the final accuracy we get on the training set, we'll have to check the same on the test set, is averaging around 0.86. That's really good. That means that out of 100 observations, you have 86 correct predictions. So, congratulations, you made a very good first deep learning model. You can be proud of yourself. And mostly now you can take a little break because we're going to enter part 4. And not only we're going to enter part 4, but also you're going to see that you're going to have a little homework which will consist of predicting the result of a single observation, meaning a single customer. You'll have to predict if this customer will stay in or leave the bank. You will enter your solution here and we will implement the solution together in the next tutorial. So make sure to do it. Please try at least to do it. You actually know how to do it because we already learned how to do a single prediction before, a prediction of a single observation. So you have everything. Maybe check out again part 3 classification if you have a doubt. But there you go. That's your homework. You have to use our ANN model to predict if the customer with the following informations will leave the bank, yes or no. And these following informations are that it is a French customer with a credit score of 600, a male one. He is 40 years old. He has been in the bank for 3 years. He has $60,000 in his account. He has 2 products in the bank. He has a credit card indeed. He is also an active member, and he has an estimated salary of $50,000. And the question is, so should we say goodbye to that customer? Well, please figure it out, and we will see if you're right in the next tutorial. Until then, enjoy machine learning.